All right, so now we're doing 8.3 and we're doing problem 14. So this is apply trigonometric substitutions to evaluate the indefinite integral. So we'll zoom in at the end of this so we can see it. But 14 is integral square root, what was it? 1 minus x squared. 1 minus x squared. So this one has a lot of those identities, so I'm going to be looking back at the book because it's almost impossible to memorize all those. But this first identity, we know that this, oh wait, dx. We know that this is equal to, x is equal to sine, I believe. And that means the dx is cosine, obviously. So dx equals cosine. So we plug this back in, we have the integral and the dx. So we have integral cosine times, cosine, which is just equal to integral cosine squared dx. So here we could do this, but it's going to be easier if we turn it back into, if we do it into terms of theta, because there's another identity we can use. So cosine 2 theta is equal to 1 plus cosine 2 theta over 2. So instead of doing this, we're going to turn it into into terms of theta. So what did I say again? 1 plus cosine 2 theta over 2. Okay. So we have integral 1 plus cosine 2 theta over 2. So here we can take out this 2 to have 1 over 2 here. Yep. So we can take out that. So we have 1 over 2 integral 1 plus cosine 2 theta. And here we can just take this integral. So we can do, let's see right here, I guess. We're gonna run out of room. 1/2, we have theta plus integral this, we have to bring this 2 over. So we have 1 over 2 cosine, but it's integral, so it's sine 2 theta. Yep, so we have 1/2 theta plus 1 over 2 sine 2 theta. So I would leave it as this, but we have to turn it back into terms of x. So there's one more, I think there's one more identity we can use here. Let me check the book again. There's so many you have to remember. Okay, right, so sine 2 theta, one of the identities is to turn it back into the terms of x. We have 2x square root 1 minus x squared. So if we turn this back into sines of x, this theta will go back into that arc sine. So we have, let's just do this equal to here. We'll have 1 over 2 times arc sine plus 1/2, and then instead of this sine theta, we have that identity. We have 2x square root 1 minus x squared. So what did I just say? 2x, yeah, 2x, okay. 2x square root 1 minus x squared. And yeah, this, oh, plus c. We got a plus c here too. So this looks good. Okay, we can simplify this. This is actually this is the full thing. We don't even need to change this, arc sine x. But we can just simplify this so we can have a nice answer at the bottom. So we'll have 1 over 2 arc sine plus x square root 1 minus x squared plus c. Okay. So let's just do this. So we started with this up here. We knew that these were the identities for that. So we changed it to have integral cosine 2x, or cosine squared dx, and then we changed it to, in terms of theta, to be able to do the integral of it easier. Then we changed this to that theta turned into arc sine, and then the sine 2x turned into this 2x square root 1 minus x squared. And we kind of simplified it a little bit just to make it look a little better. Arc sine, oh, wait. I just found a little error. This is arc sine x plus x square root 1 minus x squared plus c. Yeah, that looks right.